Alright, so inverses is what we're learning today. And what we're going to do is we're going to do this activity first, and then I'm going to have some volunteers come up, and from what we learned, we're going to see if you visually understand what's happening with inverses. Look, I have an animated video for you that I'm going to create in real time in front of you that will show what inverses is. I have this picture graph activity that will also graphically show you what inverses are. Also, we're going to look at it as far as equations go. Homework, we'll probably get to 3, maybe 4 if time permits, of what all this is talking about. Now, I want you to keep this in your head. The best analogy that I could come up with was this. How many of you have Instagram? Okay, in Instagram, there's a little app. Some of you may use it, some of you may not. It's called Boomerang. So when you record a small little segment of video, you'll see it in forward motion, but then you see it in exact opposite reverse motion. Look at the words that I just used. Opposite reverse motion. If you can understand what that means today, inverses are cake. And I'll tell you right now, inverses, a big part of it is what you've been learning in Algebra 1 and what you will continue to learn in Algebra 2. It's the backward processes of you trying to solve for a variable. If I say solve for x, get x alone. If I say solve for y, get y alone. Do you understand? Okay, here we go. First of all, I have a function that's established as f of x. And I have several x input values that I'm going to plug into this equation and see what it spits out. Anyone. If I throw in a -3, what would I get as a y value? -2. Or -3, my bad. You'd get -3. Because a -3 minus a -3 is -6. And that divided by a +2 is -3. How about if I plugged in -1, what would I get? -2. Because a -1 minus a 3 is the same as adding another negative to get a further -4. That when we divide by +2, we get a -2. Let's plug in 1. -1, because 1 minus 3, I hear a lot of negative mistakes. If we got to clean up, 1 minus 3 would be a -2. Divided by a 2, -1, right? How about if I plugged in 5? It'd be 1. Nice. So what I want you to do right now with me, in a red graph, because we're using red pen, is I want to plot these like you did way back when in Algebra 1. -3, -3, put a dot. -1, -2, 1, -1, 3, 0, and 5, 1. From there, I want you to go ahead and graph it of what it would look like as a line. And let me go ahead and make this line red. Okay. So real quick, I'm going to put arrows on this because this is a line. And now in blue, or a different color, I see some of you use different colors. That's good, especially for this unit of the things that we're doing. We're going to interchange or switch the x and y's. And you're going to see why here in just a bit. So what I want you to do is I want you to imagine flip-flopping this x and y. So what used to be an x right here at -3 is now going to be as a y value right here. This is now here, so on and so forth. So when I switch them, that's exactly what I'm doing. I'm flipping them to get -3, -2, -1, and 1. Any questions before I continue? The very first step of what you're learning today is flip the x and y. Okay. Now let's plot this in a different color. We're going to plot them just as normal graphs, okay? -3, -3. However, this one's -2, or -1, -1, +1, 0, 3, and 1, 5. And we're going to connect this with, you guessed it, a blue line. So that one's a little bit off, but I'll shift it here in just a bit. Alright, so it's going to have blue arrows. And there's our lines. Are we good, guys? Okay. Number 3, we're going to look at the blue function. And it says, write the equation, and we're going to write it in y equals mx plus b. The easiest way I think you should do that is go to the b, otherwise y-intercept, which is 3. And then from there, let's figure out the rise over the run. So the rise over run is going to be up 2 over 1, up 2 over 1, up 2 over 1, because you're going corner to corner. And I know it's a little bit off, but what's the slope? Anyone? 2. So we're going to put the slope is 2. So our blue function ends up becoming the following equation. Y equals 2x plus 3. Now, they try to make it difficult. They say an inverse function is this. And we're going to see what that means here soon, very soon. This is the inverse function. And they want you to call it, for this example, g of x. So just write g of x is 2x plus 3. Okay. For your homework, I want you to understand what just happened. They gave you this, you gave them that. You with me? And they're inverses of each other. Imagine the boomerang. They're backward processes from one another. But on your homework, if I give you a y, I want you to give me a y backwards. If I give you an f of x, I want you to give me this symbol. If I give you a g of x, I want you to give me this symbol. You with me? Now what you're learning notation-wise, and I know this looks a little weird, is that these are the inverses. In other words, if I were to match them up, this thing that we got down here, those are the inverse functions. The original thing that we were given, I'll do this now in, let's say, green. This was the original one. But if I give you y, what do you give me back? Y. Questions? Okay. So, some of you are looking at this and you're like, what is that all about? This is boomerang in reverse. This is just regular playing the video forward. You with me? Questions? Okay, so now let's go ahead and answer the other questions. Number 4 says, what do you notice about the 2 lines on the graph? Anyone? What observations do y'all see? Go ahead. Anyone? Don't be shy, please. Here.
The slopes, they change reciprocal.
Okay, so this slope over here was a 1/2, and this slope was a what? 2. A 2? So they're just reciprocals. I heard it over here. The misconception sometimes is they have to be negative reciprocals, but they don't. They don't have to be negative reciprocals. Because negative reciprocals, guys, if I have a slope of 2, and if I have a slope of negative 1/2, you see what I'm saying? The slope of 2, the negative flip of this, since it's over an understood 1, is negative 1/2. So that would look like this. And this will meet at 90-degree angles. This one does not have to be a negative reciprocal. You with me? Now, furthermore, you'll start asking yourself, do they even have to be reciprocals? And I'll tell you right now, they don't have to be reciprocals. You with me? They do not have to be reciprocals. We'll look at the graph and we'll see why. So another observation. What do y'all see? Yes? Okay, that's a big thing. They intercept at this specific location. Other things. this is going to lead me now to the activity that I want volunteers to come up. And I'm going to show you visually what's going on and how you can easily identify it from a graph of what is an inverse. The beginning will be easy. The other part is going to be a little tricky. Depends on whether you are good at spatial intelligence or not. Spatial intelligence is like sports, band, marching field, stuff like that. Like if you're walking around, let's say, the spatial awareness of this room. If I was walking away and shot it into the basket, did I make it? Did I get close? That kind of stuff is spatial awareness and intelligence. Some of you are good at that. Some of you might struggle a little bit with it. Okay? Watch. Let's look at... I need a volunteer. Anyone? Come on up, Ethan. Now, what I want Ethan to do is this right here, the y-axis, is a mirror. Okay? Imagine that it's a mirror. And everything that I do over here on the left side of this y-axis, he's going to mirror it at the same time on the right side of the y-axis. So his goal is that if I fold it over like a piece of paper, his graph would lie on my graph, vice versa. Like a mirror image. You with me? Mm-hmm. All right, here we go. So I'll start here. You ready? Now, as I move, watch me and mirror what I do. Okay? Where should... That was really good. No, that was really good. We need to end up right here at the same point. He did actually really well. That's good. We ended up at the same time. And if I folded this over, let's pretend that Ethan's photo, right, is all paint. And if I folded this over like a piece of paper, like I don't think I can fold it. I'm just curious. No, it won't let me. No worries. Oh, there we go. Okay, so something like that, right? If I fold it like a piece of paper, it would land right on mine pretty much. You agree? Nice. All right, have a seat, bud. All right, so let's have another person volunteer. I'll make it a little bit more difficult. Yes. Anyone? Come on up.
Oh, I'm going.
All right, here we go. So same thing. Our mirror image is the y-axis. Here we go. Ready?
Okay, wait. Yes. Oh.
Perfect. That's good stuff. That's good mirror image. Okay, have a seat. So now, let's make it more difficult. It's gonna get real pretty soon. Aaron, come on up. We're going to now reflect it this time on this mirror. Okay? So this is my mirror, and I'm going to reflect. I can't wait. So we're going to reflect this. Sorry, I'm excited. We're going to reflect the graph across y equals x. So I'm not folding the paper here. I'm folding the paper here. All right, here we go. Let's go. You ready?
Yes.
All right, so I'm going to start. I'm going to give him a little bit of time to kind of get his bearings, figure out where he's at, where he needs to be, because it's all about where he starts will determine if it's mirror like mine. All right, here we go. Ready? That's a good start. I mean, it's okay. It's okay. Here we go. Ready? Here we go. Watch. Oh, wait. Keep going. Okay. Have a seat. All right. That was a good attempt. So, listen. Listen. When you guys are watching Dance Dance Revolution on let's say, Xbox, sometimes you'll mirror what you see. If the thing moves his right hand, you move your left, right? Or if they move their left hand, you move your right. But sometimes some people get it mixed up, and they're like, no, I know orientation. If they move their right, I got to move their right. Or, you know what I mean? That's what's happening here. Now, imagine that this has paint all over it, and if I were to fold it over, would it create mine? No. So, let's have another volunteer. We'll do two more. Come on. Let me erase this real quick. All right, Brandon. All right, so the same thing. We're going to start, and it all depends on where he starts, right? So here we go. No, let him go. Let him go. All right, you ready? Ready, set. Oh, he almost had it. That was almost perfect. That was perfect. That was good stuff. Look at this. Nice job. Have a seat. So if I fold this across y equals x, it would lie. Watch. This piece right here would become this piece right here. This piece right here, would become this piece right here. And finally, this piece right here would become that piece right here. That was awesome. That's nice stuff. And it was folded across y equals x. Chances are he's probably good at a sport of some kind or some kind of spatial intelligence. I'm willing to say basketball because I heard him and Bo talking about basketball. All right, here we go. What I want you to do now is, let's go to the graph right here, and we're going to answer this question. The question is, number 6. How can you tell, what do you notice about the graph? Number 4. Here's what you're going to say. The graphs reflect across the line y equals x. The graphs will reflect across, like a mirror image, across the line y equals x. And number 6, because 5 we did the activity. 5 is what we kind of did together, so just eliminate 5. I like what we did. Go straight to 6. And it says on 6, how can you describe the graphs of f of x and g of x with respect to the graph, with respect to the line y is equal to x? All I would say is, if you folded f of x across y equals x, it would land on g of x. So you could write something. If you folded it like a piece of paper, the analogy that I gave was the paint. If you folded it over, it would land on the other function. Okay? Number 7. Number 7, number 8, number 9, they all tie to each other, okay? Let's see what that's talking about. Now, we just did the graph, and the graph you guys did very, very well. We're now going to go to the algebra part, okay? Here we go. First of all, number 7, number 8, number 9, we're going to look at this composition, that composition, and then see what's going on. Okay? Let's look at what our functions are. First of all, we were given f of x is x minus 3 over 2. Is that correct? I can't see the top. Okay. Then we were given the inverse function, which you will write like this on your homework. We were given the inverse function of 2x plus 3. This was the boomerang or the video going forward. And this was the video in reverse. Go with me? Okay. Now, what we're going to do in number 7 is we're going to do f of g of x. That means we're going to take g of x, which is all this, and we're going to plug it into f right here. So let's build our formula. Our formula is something minus 3 divided by 2. Anyone, what am I plugging in? 2x plus 3. When I plug in 2x plus 3, wait, before I do that, let's build the other one first, and then I'm going to ask you a question. Let's look at g of f of x, okay? G of f of x says, I'm going to take f first, and then I'm going to plug f of x, which is right here, into g. So if I plug it into g right here, my equation that's going to be built will look like this. 2 of something plus 3. And I'm going to plug what in? What am I going to plug into that one? Yes, x minus 3 over 2. You guys are killing it. Awesome. Now watch. If I told you right now, simplify what you see, which one's easier? The one in red or blue? The blue? Red. Okay. I would say 80% of you would probably say red, because fractions tend to be a little bit tricky for us by hand sometimes. And I'm telling you, I can eliminate that in a day, in 5 minutes. Okay? Watch. This right here is easy because for y'all, seeing cancellations of 0 are easier than seeing cancellations of 1. Now watch. Guys, what does the top simplify to? The entire numerator, what would it simplify to? 2x. Let's simplify more. What would that simplify to? X. So a lot of you said 2x very confidently and loud, because you can see when numbers cancel to 0. And you will cancel to 0 when you're adding and subtracting every time. You with me? What's the opposite of 5? Negative 5. What's the opposite of 10? Negative 10. And when you add them, they cancel to 0. Over here is where people fall off a little bit. Because when I asked you, what does it simplify to here? Not many people answered as much as the first time. So this simplifies to x because this is a cancellation form of what? Division. Of 1. Okay, you're right. It is division. It's division and multiplication, but it's simplifying to 1. So 2 over 2 will simplify to 1, where x is left. Now look, what just happened here is about to happen again. So if you struggle with fractions, look at this. We're going to reprogram a little bit of how we see fractions. This right now is 2 times that entire parentheses. Do you agree? If I put 2 over 1, it's going to make things clearer. Watch. Because you learned in 5th grade, maybe 6th, that when you multiply, you're just going to multiply the tops together, and you're going to multiply the bottoms together, and you don't even have to worry about whether there's a common denominator or not. You only need a common denominator when you're adding or subtracting. You with me? So, here's what I'll say. When you were in 5th grade, 6th grade, whenever you were doing this, they said, multiply all the top together, multiply all the bottom together, and then over here, you're going to simplify. And I think that's why a lot of people struggle with fractions today, in 10th, 9th, 11th, whatever grade. Because you shouldn't simplify way over here at the end. This helps with SAT, ACT as well. You need to simplify as early as possible. Okay? Watch. So if I multiply, let me put that in red. If I'm multiplying these two, you tell me, what's 2 times 3? 6. What's 3 times 2? 6. So multiplication and division, multiplication doesn't have order. Order doesn't matter with multiplication. What else doesn't have order? Addition. 2 plus 3 is 3 plus 2. But the ones that order does matter, and all these concepts that I'm telling you will make the year very easy and build your skills if you have little weak skills with fractions especially. Which one does order matter? Which ones? Division and subtraction. Here we go. So I could write this, if I wanted to, as 2 times x minus 3 over 2 times 1. I could make those change so that this is right here, so that a lot of people see that cancellation and they see that form of 1. So when I'm multiplying by 2 over 1, this 2 will simplify with that 2 to a form of 1. You with me? What's left? X minus, or don't go too far. Oh, yeah. Okay, this is a good mistake to make. It's not x minus 6 because you just canceled the 2. And now it's become 1. It's just x minus 3. So look, guys, forms of 1 look like this. Those numbers went away, and an understood 1 is left over. You with me? Now, I still have this plus 3 to contend with. What's my final answer going to be? X. What kind of cancellation form happened there? A cancellation form of 0. You with me? If you can get these in your head, the same concepts with harder things, it looks hard, it's not. But with more stuff, it's going to be very easy for you to factor when we get there. Yes?
So, couldn't you just like without having to do like the kind of like the 2/1 times x minus 3/1, like with that whole thing, you could just cancel out the 2's and then cancel out the 3's and then be left with x.
Yeah, same thing. No worries. Let's move forward. 9. It says, what do f of g of x and g of f of x have in common? Here's the thing. In your homework, and this will help you with the homework. If what you got here is the same thing that you got here, then f and g are inverses of one another. One's the forward video, and one's the backward video of the same video. You with me? Any questions? Alright, so let's go to a visual for fun. So, let's say that I have this, and I have this,
It's a car. That's a CBFRS.
and I have, let's say, that, and we'll keep going. Come over here. Let's put, actually, you know what? Let's put it, I want some rims. I want some rims. Alright, ready?
Oh, you're taking a brain break real quick?
Yeah, we're taking a baby break while you see what I'm trying to develop for you. Alright, so, real quick. Alright, we need to make this cooler. Let's put some spinners on this. And let's put some spinners on this. Alright, cool. And you want nitro? Let's put some nitro on this. Let's put a spoiler. Sort of, right? And then let's put an exhaust. Right, let's put some flames. Let's put some, right? Sort of. That's good enough, right? Dude, this is awesome. Alright. So, whoa, that looks awesome. Alright, so, here we go. Ready? We're about to build f of x. We're building, that's an awesome car. Alright.
Yeah, you need to like copy that. Like,
Ready?
keep it.
Here we go. So some spinners. We're going to get some little exhaust.
He's getting way too
We're going to get some spinners going on. Let's create a door handle mid-segment. We're going to give it some... So, we're going to go like that. Oh no, my tire! Come back, no worries. We will collect that tire back. Stay with us.
This is the,
We will erase exhaust.
like, how come my parents not learning?
We will fall down. We'll have some more. We'll have some fire blowing out. I know. And then we'll keep going. And then we'll ramp it. We'll ramp it. We will ramp it. And we... Oh, I don't want to get rid of the exhaust. It's lovely. And it just appears. Alright, cool. Look that way.
That was
I have
really
a
good.
surprise for you. Look that way. Look that way. Don't look back here. Don't look there. Ryan, don't look back here. Alright, don't look, don't look, don't look, don't look, don't look. I'm surprised. Don't look, don't look, don't look. Alright, here we go. Now you can look. Ready? What we're going to do is we're going to put this in f of x motion.
Wait, the door handle's on.
We're going to put this in forward motion. Here we go.
Door
Ready?
handle go. Oh, there it is.
Oh!
That was f of x. Alright? That was f of x.
That was cool, dude.
Here comes g of x, or the inverse of f of x. So it's the same thing, only everything
Its door handle goes away.
Dude.
Cool. Now, that's what's visually happening with inverses, okay? Oh man, it's okay. It's all good. Alright, so, here we go. To your homework. I want you to see visually what we showed, graphically what we showed. It's actually quite easy to do it homework-wise, but I want you to understand why did I do all that, okay? Here we go. First of all,
Giggles.
we are going for the inverse of this relation that you see. So put everything that you learned together. And I have 4 points. What do I do? Switch the x and y. Please don't do the negative swap because we never mentioned that. They just swap. Whatever they were, x becomes y, y becomes x. And you would get something that looks like this for number 1.
Can we do that?
Okay, that's one. That's one level. There's other levels, but they're all just as easy if you understood what I was trying to tell you. Alright, let's go to, let's start with an easy one. Let's start with number 3. We have 3x plus 2 is equal to y, and I showed you the most important step is the x and y flip. So I'm going to show you right here. If you see an equation, flip the x and the y. Everything else stays the same. That's step 1. It's kind of like what you just did on the first problem. Okay? You just flip the x and y. Now, your second step is to get your y all by itself. So solve for y. That means get y alone. Okay? Some of you are very good at this, especially the harder ones. Some of you struggle. And I'm going to show you something that can help you catch up and even be faster than what you are now. Those of you who are good at this. I want you to get y all by itself. What do I do to both sides?
Subtract.
Subtract 2. So I have this. Now, let's get a positive y by itself. You obviously, we're going to do what? Divide by 3. There's a cancellation form of 1. So what I have left over is y is equal to this. Now, some of you don't feel comfortable with that. You prefer to write it like this, which is okay by me. This is the f of x. So I know that I did not give it to you in f of x, but had I given it to you in f of x, this would have been the inverse of f of x as far as an answer is concerned. You wouldn't have written y's. You would have written the inverse of f of x. Don't get confused of what's going on. Same thing. Now, let me show you a shortcut. PEMDAS, order of operations. A lot of us, when we see equations like this, especially when they're more difficult looking like number 9, which we're going to do in just a bit, we struggle to see what should we start moving to the other side first. But a lot of us are really, really good at this. So I'm going to use that strength. Imagine in the very, very beginning, right here, on my original problem, that your body is where x is at, where I have it highlighted in blue. What would you do to that x value? So put your body where x is. What would be done to you first PEMDAS-wise if I were to list it out going forward? No. Going first in regular order, I would multiply x with 3. Follow me. I would multiply x with 3. That would then be this thing. What would I do with what's left now in green? After that, I would add 2. You with me? All I did was list the steps of normal forward PEMDAS order. And in case you haven't realized this by now, when you solve for a function, or when you solve for a variable, aka get x by itself, get y by itself, all you're doing is the inverse process. You're doing everything backwards like the car coming backwards. Okay? That's what's actually happening. So the shortcut is this. I'm going to do these steps, but backwards, almost like that boomerang analogy. And I'm going to do the opposite operation. That means when I go backwards, I'm not going to add by 2. I'm going to what? Subtract by 2. So take an x, any x, and we're going to subtract by 2. Now that's gone. What's the next step that I'm going to do backwards opposite? Divide by 3. And real quick, I can get to my answer, which is the inverse of f of x. Okay? Let's do the ones that are more difficult. Listen, this shortcut will work 95% of the time. When it doesn't work, I will show you what that looks like next class, but you got to get some homework practice under your belt, okay? Let's go to number 9.
This isn't going to be on the quiz.
This will not be on the quiz. Today's lesson is not on the quiz. Everything else before that for sure is. All right, here we go. Let's do number 9 together. We're going to do it the long way because we have to learn the long way. Otherwise, that 5%, when the shortcut doesn't work, you'll have no clue how to do those problems, okay? Here we go. First step. What's the first step? X and Y switch. So we'll have x is equal to negative 5/8 y plus 10. Second step, solve for your new y. Get y by itself. Some of you can see it. Some of you maybe not as easy. What do I do to start moving stuff over? Subtract 10. Okay, here we go. X minus 10 is equal to negative 5/8 y. My goal is to get this y all by itself. Now, think about how I'm trying to teach you, okay? The ways that I'm showing you reduces the confusion and reduces common mistakes. And I'm talking about whether you want to get a 36 perfect score on an ACT or a 15-20 perfect score on a PSAT. The things that I'm showing you are not just to pass the class, it's to master the material, okay? Now, if I'm looking at this and I wanted to get y by itself, I want to hear your suggestions. What do I do to both sides?
Multiply by -5. And then just get the...
Okay, here we go. He's saying more than one step. I'm saying a one-step thing. What would I do? Yeah. Is that what you were going to say? I'm going to multiply by -8/5. This is why. Look up here. If I'm multiplying right here and here, we learned today that multiplication order doesn't matter. What would this 8 in the denominator and 8 in the numerator cancel out to become? 1. Multiplication and division, no worries. Multiplication, write it down if you missed it. Multiplication and division will cancel to 1. This is the same as if you wrote it like this. I know it doesn't look the same because this 8's way over here and this is way over here. Guys, it's the same as this because order with multiplication doesn't matter. It could be anywhere on the top. You with me? So what does this cancel again to? 1. What do the 5's cancel to? 1. And what do 2 negatives that are multiplied together give you? A positive. So all that, I'm left with a positive y on the right and this on the left. Now, someone asked me earlier today, first of all, do I have to change this because of the way it was given to me? Do I have to change that as a last step to the inverse of f of x? Yes or no? No. It was given to me as y. I can give it back as y. The question that was asked was, do I have to simplify and get rid of parentheses? You don't. This one time on this homework, you don't have to. If you want want to, you can. But the reason why I don't want you to is so that you can see, does your answer match my shortcut answer? Watch the shortcut. Here we go. Put your body where X is at. The first thing that would normally be done to you, PEMDAS wise, let me see if you're understanding my analogy. What would be done to you first if you were at X right now? What would be done to you first, PEMDAS wise? Normal order. Multiplied by what? Yep. Multiplied by negative 5/8. Then now this is you. Then you would add 10. So we're going to take an X, which is right here, and we're going to do the backward opposite. So we're not going to add 10, we're going to subtract it. We have to put parentheses now because this is our running answer. And a lot of people fail to put parentheses and they don't understand the shortcut. Now what are we going to do? Okay, so dividing by negative, watch. Dividing by a negative 5/8, if I did that, it would look like this. And people are like, whoa, what's just happening right now? But 5th grade helped us out because dividing by negative 5/8 is the same as keep, change, flip. Dividing by a fraction is the same as multiplying by the reciprocal of that fraction. We've learned that. So now I'm multiplying by the negative 5/8 and it looks just like my answer did over here. Raise your hand honestly if you like the shortcut.
By the way, I didn't see what you did again. I was writing down the
All I did was multiply by the reciprocal. So I get a negative 8/5. We're going to go to one example. If you didn't see it, please watch the video, pause it. That's why I'm creating the video, okay? Let's go to one more example of verifying inverses. All right, here we go. This is for verifying if those two functions are inverses of one another. In other words, is this function f, the backward video would be g of x. Do you understand what I'm saying?
Yes.
All right, here we go. The way you do this is you have to see what is it that I would get from that composition and compare it to what would I get from this composition. Remember, we did this earlier in notes. What did they both simplify to? X. Now here's my question. If they're equal, are they inverses? Yes or no? Yes. But what if you don't get X? What if you do all that work and you get something that looks like this for one of them and this for the other one? Are they inverses? Yes. Because as long as they're the same answer, they're offsetting each other. Okay? So this backward process will end up offsetting the other thing. Most likely you're going to get X and X all the time. But sometimes, depending on how people simplify, they may get a little bit more stuff than just X. Okay? So ultimately, here's the thing. If they're the same answer, they're inverses. But if anything is slightly different, they're not inverses of one another. Okay? Let's do an example, maybe two. I'll let you choose. Which of these do you want to do? Number 19. Here we go. Let's do f of g of x. I'm taking this right here and I'm plugging it into f. Okay? So let's build this function. I have parentheses plus 6 and we're plugging this right here. What do we get? We get x. Let's do g of f. We'll have time to do one more. Just relax. Just think about it. Which one y'all want to do here in just a bit. We're going to take f now, and we're going to plug it into g. So it looks something like this. What do I get? X. Here we go. Are these the same?
Yeah.
So then f and g, yes, they are inverses.
Just put yes.
well, I want you to make sure that you know what you're saying, okay? With this being yes, what was I going to say? Oh, this is what I was going to say. The answer yes doesn't get you full credit. All this work is the proof that you verified or proved that they are inverses. Now, the proof, we did proofs in geometry. A lot of us didn't maybe like those proofs. It's not the same level at all. These proofs are just doing algebra to verify. All right, one more. Which one? 22, let's go. 22, we're going to put f of g of x. Then we're going to do g of f of x. So if I do g and I put it into f, it will look like this. However, on the other one, if I put f into g, let's build g real quick. We have something minus 2 over 5. We're going to put all of this f of x right here. What does the top cancel to? 5x. Nicely done. Nice speed. What does it now fully cancel to? X. Let's do this one. Think about what I showed you today. If I'm multiplying this across, this is the same as 5 over 1. You with me? Ask yourself, does 5 and 2 cancel reduce right now? They don't. So I will distribute 5 to get 5x minus 10, and on the bottom I still have 2. No, because that's a really good question. The 1 multiplies with 2 to get that. It's 5 over 1. You just distribute the top as far as 5 times that x minus 2 piece. Yes?
Wouldn't it be x minus 2 over 5?
Oh, I copied it wrong incorrectly, didn't I? No worries. So, good catch. This right here, thank you for catching my mistake, was actually a 5. So does it cancel? It actually does. It's Tyler, right? Thank you. So this does cancel to a form of 1. So I'm left with x minus 2. Look at that. So now there's another cancellation that's about to happen. What do you get? X. Are these obviously the same? Yes. So you say f and g are inverses. Nice job, Tyler, on that. Any questions before I stop the video? Awesome job today, guys. Awesome job.